Hello.
Hi, everyone.
Hello.
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 Hey.
So yeah, thanks for joining in again for the third chapter. Yeah, does someone want to raise something before we start? How did you like it?
I don't know. For me, it was difficult to read it. More difficult than the first chapters. I don't know why.
Yeah, I found that sometimes I think it goes too much into detail, or maybe it's good that it goes into detail, but sometimes I felt like skipping a few of the details because, I mean, I could spend a lot of hours on this to understand everything, but sometimes I felt, okay, I need to read this and maybe it makes sense in the bigger picture later, but there are so many details in it, and yeah, I think it just depends on how much time you want to spend on it.
I agree. I also had an issue like to understand sometimes because it's explaining what but not why. So also it's skipping some things where you think like, okay, like there's this string variable assignment like in one stack operation and you don't know what it does until the end. And then he explains rarely what it does. So it's like the phase how he builds it up is a bit hard to understand.
Yeah, but thanks for sharing that, because it's nice to hear that I'm not the only one struggling with it.
Also, when you like see the C code and you're like, okay, I know how C code usually looks like. This is not C, and then he's like, yeah, this is not C. Okay.
Yeah.
What I found interesting was this difference that they only introduced this execution like compiler part in 1.9, and that's interesting to me. And what also was interesting that it performs a bit worse in the beginning with less instructions. So maybe like Yorick, you have been at GitLab maybe long enough that you've seen a Ruby 1.8 to 1.9 switch in Rails. Or maybe Matthias also has some insights into that. Is there, like, I would have imagined that Ruby 1.9 performs worse on Rails than Ruby 1.8 because we only have not that many instructions when we perform a Rails request.
Yeah, so the last time I worked with Ruby 1.8 was back in 2012, I think, when my previous employer ported over a bunch of 1.8 apps to 1.9, 4, whatever it was at the time. I think we didn't benchmark it that much. It was more from the sake of, well, Ruby 1.8 is dead, so we kind of have to. I think the performance, it kind of depends, I guess, on what versions they compared. Because when Ruby 1.9 was first introduced, it was kind of a train wreck. Because it was a completely different VM implementation. And if I recall, a lot of stuff was lacking and buggy. It is kind of the Python 2 to Python 3 issue, although it took less time to resolve. So I think if you compare Ruby today to 1.8, it will basically blow Ruby 1.8 out of the water. Yeah, as to why something with fewer instructions might be slower, that depends entirely on what those instructions do, for example. Typically, in an instruction set, there's sort of two approaches you can take. You can have more, but generally smaller instructions. So instructions with fewer arguments, for example, or fewer instructions with more arguments. I think I might be mistaken here, but I think Apple's new M1 chip, they take a wider approach where some instructions they have quite a number of arguments and such. It's a hotly debated topic for many decades where some people are in favor of one approach or the other. It's a bit difficult to say why in this case that might affect things, at least without digging through the Ruby implementations at the time.
Yeah, sorry, I missed the first half of the question. I had to answer the door. But this is about Ruby 1.8 versus Ruby 1.9, which introduced YARV, right? Yeah, so this switch definitely predates me joining GitLab. And in between, I had not worked on Ruby for a while as well. So my Ruby 1.8 experience is, yeah, it was a long time ago. So I can't give you any specifics as to how that compared for a specific app. Yeah, like outside of what Jörg said already, my understanding as well is that the main benefit is to move to a bytecode model, that's the main thing Jörg accomplished, right? It moved away from interpreting the AST at runtime, because that is basically it is kind of a normalized form of your program as well, because it happens after tokenization, but it is a much less efficient way to represent your program, because it is still it is not as condensed as bytecode might be. Although again, that also depends, like Jörg touched on this, that also depends a little bit on the bytecode, how you encode it. There's this trade-off between, and that I guess is I guess like a size speed trade-off. How compact. So the less instructions you have available to express the same program, the more nodes you typically need to represent that program. So that usually means it will consume more memory, but it might be faster to execute. And then the converse is true for a richer instruction set. So yeah, there's this traditional trade-off. I remember like the last time I actually had to deal with this was for Android. I don't know if anyone has ever done any Android development, but they completely changed the way they interpret or they deal with Java bytecode, right? Because the Java VM is also a stack-based machine. And they changed this actually to a register-based VM. Like initially it was Delvik, and then I totally rewrote it again into Art, but that's a different story. So yeah, that's like all these. So this, sorry, the reason they did this is because it shrinks the executable a lot. So like early on, the Android devices were super weak, right? Like you didn't have a lot of memory. You had to fit like your whole application into a few megabytes of memory. And yeah, so this helped reduce the size of the binary a lot and what you have to load into memory. Yeah, and like another benefit I can see of this approach YARV takes and bytecode is JIT, and also reusing. So a just-in-time compiler can actually come along and take some of these chunks of bytecode and compile it down into native code, and then also and like be able to reuse that and execute this faster than ordinary Ruby code as it would otherwise be represented in memory.
Also, part of the question was if there's a big performance impact for Rails because it's rather short-lived. And I was wondering if Rails in production, because if I understand correctly, the thing that makes Ruby Ruby slow is what is slower is to compile it before it runs, and then when it's compiled, it's actually faster than 1.8. But for Rails, if it runs in production, does it compile once at startup, or does it require compile on every request?
Yeah, that's a great question. So this actually, you have some influence on this. The way we run, and this is maybe not Rails specific so much, but rather how you run your application. So we use a pre-fork server, and Sidekick operates similarly, or at least the way we run it, where you have some kind of main process that you fork other processes off of. And what we do is, before we do that, we preload the application. So what this means is that the runtime will go through, it will kind of go through as much code as possible that we can see as used during the lifetime of the application. And at that point in time, this is when actually this all happens, so that you basically have the final form of the application in memory already before you even serve the first request. So that's kind of what Puma does as well. So we preload the application in the Puma master, and then there's additional benefits from this from a memory perspective, because if you then go continue to fork off workers from this the main process, which already is the application preloaded in memory, there are some savings you can have from a memory perspective, because these processes will look very similar by the time they fork. So you can the operating system is actually able to share memory between these processes. That will be totally transparent to each individual process, but in terms of the raw physical memory that's actually being used, like consumed on that node, will actually be less. So that's another benefit I can think of. But that's not so much Rails specific, rather than kind of depends. So do you front load this work? You know, the work needs to happen at some point, assuming like every line of code will eventually be executed. Then if you front load all this work of turning it into executable code that the VM can actually run, yeah, so then you expend memory earlier, but then you don't have to redo that work. But yeah, by the way, I agree. It was quite a dense chapter. I read it like a year ago, so I don't remember everything. Because I read the book a while ago, but I thought it would be a nice refresher as well to maybe drop in and see what you made of it. I still think it's nice that there is a book that actually goes into that kind of detail. And while it's not something you probably won't be thinking about this all the time, right? While writing application code, but I thought it's nice that there is a book which actually, does look under the hood of what's going on, and there's not that many. I'm not aware of any other book that goes into that sort of detail, so I thought it was kind of neat to have that. Yeah.
Yeah. Also, while I was reading it, I thought this might be something that would be helpful to look up later. Like if you run into some issues and you want to understand it, then at least know where to find the explanation. And maybe it's not so easy to understand if you read the book from beginning to end, but yeah, if you want to look up a specific thing, that's cool.
Well, as I said, for me it was like a bit difficult to read this third chapter, because like it's dense and there's so many things, details, and you have to remember about. But I figured my way to read these books that like just skip all the like small details that I not really like understand. I don't have time to like understand it right now, because I feel that we're going to, in next chapters, we are going to read about classes, like blocks, some like more, let's say, down to earth things that we are like use in everyday work. So it's good. Like, I don't know, for me, this first chapters, they are just really good to like get some understanding how it works. But I still maybe but I was trying to find like any practical, like what I can, like, for example, in this chapter, we get the list of special variables that can like show you the arguments, like error string and so on. But like, I was thinking why we need them? Like, what is the purpose of these special variables? Like, and I guess for just like for users of the language as we are, it's not really bring value, but maybe I'm mistaken.
I think I studied language design, no, language implementation in college, and I feel it's much simpler in the course because they will try to ask us to implement a toy language, which will be really simple. But I guess it's difficult here in this book since we are going head first. Everything is presented to us in the very beginning. That's why it's I guess less handleable. But I think I can still quite follow it if I read far enough and don't try to understand everything as I read them.
Mark, you have a question regarding the EP?
Oh yeah, I don't know if there's an answer or I missed the answer. So there's a paragraph saying that the paragraph first introduced the idea of environment pointer, and it goes on and say that the SP will change quite a lot, but the EP will remain constant normally. That's what the paragraph says, but I think throughout the chapter, I see that the EP is also changed. We have like an example where we have EP and previous EP. So I don't quite understand why the paragraph specifically say that EP will remain constant. Does anyone catch the reason? I assume that maybe the answer will be in the following chapters. So yeah.
It's not explained. I'm reading it again right now, but I can't find any reason so far.
Are you talking about stack pointer or something else?
I'm talking about the environment pointer. And this graph, I bought the ebook version of the book, so I copied the paragraph straight away from the book. But I don't think it's a big deal. I just wonder why the author put this here. But yeah, it's not a big deal.
Did you mean this graphic that I just pasted? It's on the second page.
Oh, let me take a look.
Also,
I could be
what?
wrong. I only skimmed it now again. It's been a while, but I think isn't the difference simply that, so the environment pointer is used to track lexical scopes, is is my understanding of it. So because every time you enter a method, you create a new stack, right? Or stack frame. So the stack pointer always will refer to the scope you're currently in. But you can, and maybe this is only important for these special variables, or if you pass a block where you have like a closure, right, where you can access data that is outside the current method scope, then you need to know where to look that up. So that's my understanding why it's talking about this ladder of environment pointers that you have to traverse to resolve something that is actually not in the same lexical scope as your current method, so that you can kind of follow the breadcrumbs back to where it was originally defined. that was my understanding. I didn't read much else into it. So, yeah.
This could be
I just pasted the part where I copy the paragraph from, but I don't have a page number. EPUB doesn't show me the numbers, but I don't think it's like it's the first time you introduced the environment pointer, so before that it doesn't really have any context. So I don't think context can be found here. Then I guess I don't like. There's no answer for this, but I have another question that I think so. I think it's implied that the virtual machine will keep multiple environment pointers. Like it has in a graph, you would say previous EP. So I guess there's a array of these environment pointers, right?
If I understand correctly the question, I think it should work like a stack. So you just got the latest, and then you just go to the one that's just like main.
Yeah, I think that's what I was trying to say earlier. I'm looking at page 71, and there's an example where we execute a block, right? A block is that's the syntactic equivalent of a closure, right? So you need to, so while you execute the block, you need to, you're able to access variables that are defined outside of the immediate scope of the block, right? So the runtime needs to have a way of finding where these are defined. So it needs to kind of be able to backtrack to, up the stack, right? To see what value they have when it executes this block. So I think this is why it needs to do some extra bookkeeping there. Because as you mentioned earlier, I think the initial value of the environment pointer, it's actually pointing to the area where the local variables of that current, the current block or method stored. So that's why it needs to, so one, it's not sufficient to like keep one pointer there. Otherwise you would lose track of what was defined outside the immediate scope of what's currently executing. I think like it sounds like this is only really used when you execute blocks, but I'm not totally sure. Maybe I'm missing something.
So this previous endpoint pointer, this is just it's a pointer. So it's an environment pointer, and I think it's the last like grayed in part where they climbing the environment pointer letter in C, where it's what you just described with the blocks, and basically gets the value based on the environment pointer minus the, it says index though. It's the it's the environment pointer, it's the previous one. So it goes to the previous one minus the index, which then leads to this value. Yeah, so you're right, Matthias. Okay, any other thing someone wants to mention or has a question? Good, then I think that's it. And let's hope that the next chapter is more descriptive and leaves us with less questions. So we see each other next week again. And I've seen a few people dislining the 22nd, I think. So maybe we want to skip that because it's so close to Christmas holidays. So like general holidays. So yeah, but we can check. Yeah, otherwise, wish you all good afternoon and yeah, have a nice day. Let's see each other next week.
Thank you.
Goodbye.
Bye.
Bye.